So the fact is that proteins are made of strings of amino acids. We know this, and we also know that there are 20 possible amino acids we can break our proteins into. So that right there should make you think, should make you wonder, how are we going to get these things, how are we going to get amino acids into the mix? Well, we actually have many different kinds of amino acid transporters. And we can transport amino acids as single things, as dipeptides, 2 amino acids together, or even as tripeptides. What happened to my peptide bond? And we're going to have different transporters to do these different jobs. A single amino acid, I'm going to give you an example. Some single amino acids can be transported in concert with sodium, which makes sense. We pull sodium down its concentration gradient. Dude, throw in a sodium-potassium pump while you're at it. Why not? The sodium will head on out, maintaining that concentration gradient, and we can continue to pull amino acids into the cell. Now, it's kind of interesting. We actually have sometimes, now this is just an example, sometimes we have an amino acid transporter, again, that can go the opposite direction with sodium. Either way, obviously, we wouldn't want to be putting sodium out into the lumen of our intestine, but allowing sodium back in, down its sodium gradient, and then pumping it back out again through the sodium-potassium pump, awesome. We can totally do that, and that allows amino acids to get absorbed from the lumen. My point is, since there are 20 different amino acids and they have great variety of chemical structures, it makes sense that we're going to need different flavors of transporters to get them in. And even having multiple different kinds. Sometimes sodium is the guy we exchange with. Sometimes hydrogen is the person that we use to carry out the absorption of single amino acids. Let's look at lipids.